section 10.7 is on circles in the coordinate plane. So now we're talking about what this would look like. We've been working with circles all chapter long, but now we want to know what's it going to look like on the coordinate plane. Okay, so we start with an equation of a circle with the center at the origin. So in other words, we have a center at 0, 0, and we want to know what would the equation of a circle look like. We have to get a curve in some way, right? When we saw curves before, we've seen parabolas, okay, where one of our terms was squared, y equals x squared plus something, okay? In order to get the equation of a circle with a radius of r, we are dealing with the equation x squared plus y squared equals r squared. That's the standard form of an equation with a center at 0, 0 and a radius of r. So x squared plus y squared equals r squared. So anywhere I go along this circle, I'll be xy away, and that x squared plus the y squared gets us r squared by the Pythagorean theorem. Okay? All right, then we can complicate it a little bit more. But before we do that, what would the equation of a circle with a radius of 3 be? What would the equation of a circle with a radius of 3 be? Absolutely. X squared plus y squared equals 3 squared. And what's 3 squared? 9. So x squared plus y squared equals 9. What would the equation of a circle with a radius of 5 be? X squared plus y squared equals 25. What would the equation of a circle with a radius of 7 be? X squared plus y squared equals 49. Exactly. Okay? So, very easy formula, right? We have a squared x, a squared y, a plus sign in the middle, and some r that's squared on the other side. What makes it a little more complicated is when we shift that circle and we don't have a center at 0, 0 anymore. When the center's not at the origin, then our equation is of the form x minus h squared plus y minus k squared equals r squared. Where h and k are the x and y coordinates of that vertex, of the center. Okay? So if the center is at hk, then x minus h squared plus the quantity y minus k squared equals r squared. Notice the difference in signs here. If my center is at the point 2, 3, they're both positive. In this equation, the 2 and the 3 will be negative. They're opposite signs. Okay? If my center was at 1, negative 5, I'll have a negative 1, positive 5 in the equation. Because if I'm trying to get the x all by itself, when the h goes to the opposite side, it changes signs. So think of your h as your horizontal movement and your k as your vertical movement. Or you spell k vertical wrong. Okay? So let's see it in action. So we have a center at what? 0, 0. Okay? So if you think about that as being centered at 0, 0, it's x minus 0 squared, right? plus y minus 0 squared. So you can still use that new form of the equation using the center at 0, 0. But what will my equation say here? X squared plus y squared. And how long is this radius? Total of 3. So what goes on the other side of the equation? 3 squared, which is 9. Okay? How about this one? That's the answer. It was 9 because the radius was 3. When we square 3, we get 9. Okay? So from the center, how far out do we go?
Oh, okay.
Okay, so that's your radius. Yep. Okay, so what's my center on this one? Negative 1, 3. Okay, so if my center is negative 1, 3, so what is it, Jake? Is it minus 1? Plus 1 squared. Very good. That's the left hand of the equation, the left side of the equation. Braxton, how long is the radius on this circle? So start at the center and count your way over to one of the to the circle itself. 5. So what's going to go on this side of the equation? So what goes on this side of the equation? 5 squared, which is, yep. So we change the signs of the center when we plug it in, and then we use r squared on the side of the equation, other side of the equation. Okay? So what if we have a circle with a radius at negative 2, 5, sorry, a center at negative 2, 5, and a radius of 7? Emmanuel, what's my equation going to say? We're going to sketch it in just a second, but let's write the equation of the circle first. Right. Just writing the equation is all we're doing. That's going to be the homework. It's very easy. So, Emmanuel, what do you think? What's it going to look like? Okay, something something equals 7 squared. So we know we're going to have 49 over here. Okay. Do we keep the signs the same? So x plus 2 squared plus y minus 5 squared. We switch the signs of the center. Because if you're trying to solve this for x, okay, once we square root things in the whole 9 yards and we're trying to get that x by itself, it's on the other side, it's a negative 2, isn't it? Okay, same thing with the y. If we were trying to isolate the y, that 5 would go to the other side and be positive. Okay, so that's the answer. Now let's graph it to make sure we know how to graph these. Let's graph it to make sure we know how to graph these. So we're putting a center at negative 2, 5. Okay. And now we're going to move 7 out, 7 up, 7 left, and 7 back, or 7 down. So 2, 4, 6, 7. I want one off. 2, 4, 6, 7. Okay. But I'm from negative 2. Okay. So 2, 4, 6, 7. But in the middle between 4 and 6, it's at 5. 2, 4, 6, 7, and 2, 4, 6, 7. Okay. Then do your best to make it look like a circle and not a football. Okay. I didn't do a very good job there. Yeah, it would look a little oval, a little elliptical. Yeah, absolutely, as long as you're doing your best. As you can see, I don't make a perfect circle every time either. All right, so the next one, we have a point on the circle. Question? I don't believe so. It might be helpful for a couple of them, but not enough to need graph paper. Okay. All right, so we've got a point on the circle that's at 3, 4, and we have a center at 1, 4. Okay, so let's start our equation out. What's our equation going to say, Jen? Be careful. Point on the circle center. Grab the right point. Yep. Yep. Okay, because it's the center of the circle. This is just a point that's somewhere out there on the circle. This is the actual center. Okay. Plus, yep, squared, right? Make them opposite. Take the center point and change the signs. Okay. Now we have to figure out what our radius is here. Because the 4s aren't changing, right? Our vertical movement's not changing, but our horizontal movement is a total of 2. So 2 squared is 4. Okay? If you don't recognize that, you can certainly graph it. We'll sketch a really quick graph. So we're at the point 1, 4. 1, 4. And then we have a point at 3, 4. So when we're 3, 4, this is the point that's on our circle. How long is that radius? 2, and 2 squared is 4. Okay? So we would be 2 up, 2 down, and 2 left. And we can graph this circle. I did a better job with that one. Okay? Because from the center, our radius is 2. Radius squared is 4. Because between these 2 points, we had a distance of 2. This is a point on the circle, and this is the center. Between 1, 4 and 3, 4, the 4s didn't change, but the difference between 3 and 1 is 2. Our radius is 2. Yep. Okay. All right. So that's curtains on this assignment. These notes. Here comes the assignment.